today. Hope you can all see my screen there. Today's agenda will be a quick overview of WVD, what it is, just to make sure that everyone understands what desktop virtualization is and what WVD is and where it's beneficial. We'll go through some architectural considerations and concepts before we go through some actual requirements. That'll be the licensing and some technical stuff. In that, we'll also cover a few things like some FSLogix and some additional things on top of that. Then we move into service and management, where we'll talk about just how best to deliver some of the stuff. And then on top of that, we'll go through some recommendations, and that's probably quite a lengthy section where we'll go through a whole bunch of things that we've gained from insight with dealing with customers, from working with other people, and just from scouring the internet. So we'll present that all to you, and then afterwards you'll have the chance to ask your questions, and hopefully we'll be able to answer those. So, brief introduction to WVD. So what is Windows Virtual Desktop? Well, more precisely, what is a desktop virtualization and why is it beneficial? So desktop virtualization is often considered a solution for enabling central management and security of your users' desktops, ensuring less IT management overhead. This allows that separation of the operating system, the data, and the applications from local hardware, instead running them on a remote server. The main appeal is you can separate that compute environment from your user devices, that greatly reducing the risk of confidential information being left on devices and other such risks. So why WVD? So traditional desktop virtualization environment, if you've ever had the chance to play with things like RDS in Windows Server or Citrix, is often prohibitively expensive and very technically complex. A successful implementation can take weeks or months to complete, and often the user experience may be lacking compared to that of a locally provisioned desktop. Windows Virtual Desktop removes that complexity by providing that backend infrastructure as a fully managed service. This includes all those roles that you traditionally need, saying like RDS, such as a gateway, the broker, diagnostics, load balancing, etc. Compared to on-premise, you benefit from the immense capacity of Azure without having to deploy and maintain that backend infrastructure for that environment that you're presenting to your users. You can still retain full control over the VMs and the system images you use. So when is this desktop virtualization useful? Given some examples there, but desktop virtualization helps organizations address those specific operational needs, such as keeping that data and organizational resources safe while enabling appropriate access to specific users. That's quite beneficial in, say, the security and regulation of health services, government, and that sort of environments. Access to IT services on demand, especially for those increasingly elastic workforces. If you have customers who are dealing with short-term employees, contractors, additional partners that need access to your resources, WVD might be very beneficial there. You also might have specific employee needs, such as bring your own device call centers, and obviously being remote. For most of us being remote nowadays, being able to provide access to your users when they're working from home and making sure that they have that flexibility, even outside of, or hopefully once we get into some more normal situations outside of COVID, a lot of customers who are looking at using WVD for that remote access and the flexibility it offers, a lot of those customers are going to continue utilizing that, or at least in part, to their users to be able to provide that working flexibility to support more modern types of working, to be able to support users' flexible working hours and that sort of things. And then obviously for specialized workloads, it's also very beneficial. One thing that we've seen that a lot of our customers utilize a lot is for legacy applications, where you have a customer who has a line of business application where it's not going to be refactored or at least rebuilt within the cloud. It just needs to be lifted and shifted into the cloud, and WVD can offer that very easy access to that in a secure way without exposing that application to the internet directly. So onto the architecture. In terms of WVD architecture, there's three main sections. There's the clients, which is something that as a partner or a client will actually manage themselves. Those clients can be anything, pretty much. Windows native client is supported. There's a Mac native client, iOS, Android, and even a HTML5 ability. So you can pretty much utilize any device as long as you have either a browser or one of those other 4 devices which have native client support. In the middle of that is this bit that Microsoft provides. That is the PaaS service, that is WVD. So what we don't get to see and actually utilize is all those services that Microsoft provides, such as that web access, those diagnostics, that gateway. And if you're familiar with RDS, then those sort of terms will be familiar to you for what RDS supplies. And it's very similar within the back end of Windows Virtual Desktop that provides that infrastructure to you. In terms, the other thing that you then need to consider as a partner or as a customer is the applications, the desktops, the virtual machines, all of that sits on some potential storage for FSLogix and any other services that you require to build out that solution. So the WVD solution, the part that Microsoft manages, is just that access and the ability to use that service, and you don't have to worry about managing and maintaining it as it's a PaaS service. You just have to configure it. So some WVD terminology that we're going to use a lot during this discussion, and it's just good to make sure that everybody's on a understanding of what these are. So the main one is the workspace. Well, when a user logs in, at least, the first thing that they'll see is the workspace, that they'll be able to access their applications. So literally that could be some remote apps or some desktop apps. From the hardware perspective, there's something called the host pool, which is that collection of virtual machines which act as those session hosts, and they can either be pooled or personal, and we'll go into further detail about that. And then we also have something called application groups, which is that remote resources that the user can connect to, and those will either be the remote apps or remote desktops. Host pools, as we said, are one of 2 options, pooled or personal. Pooled is the most common that we find with most of our customers. That is when a user utilizes or multiple users utilize a single virtual machine, a single session host, in order to access resources that are associated to them. This is very similar to old school Citrix type environments where basically a number of users will be able to RDP into a server. Same idea with host pools. These are very useful when you want to limit costs, for example, because it is the most effective option. You have multiple users using a single virtual machine. The density that you can get out of that, especially relative to cost, is going to be a lot lower than, the density will be higher, but the cost will be lower than if you were to use personal, which we'll get to. And in this case, you need to make sure that the number of users utilizing a single physical machine, single virtual machine, is going to be sufficient to support those user requirements. And we'll get into some of that during the recommendations section later on. A personal desktop is that host pool will be where you have remote desktops or remote apps where a user requires access to a high performance session host. That session host will be dedicated to themselves. There's actually 2 options within that. The default is a user will get any session host within that host pool, but there's the option to actually have that direct assignment too. This is usually used where you have a user which requires admin access, or they require high performance access to a specific workload that they're doing, which we'll also go into a bit later. Associated with the pooling especially is load balancing. So this is default provided by the solution is either breadth or depth load balancing. So in breadth, basically what happens, you'll have a number of virtual machines, session hosts in that host pool, and basically what will happen is a user will, when they log in, they'll be assigned to a virtual machine that hasn't yet, that doesn't have or has the lowest number of users associated to it. So if it's the first user of the day, they'll go into one of the first virtual machines. The second user will go into a different virtual machine. But once you hit the number of virtual machines plus one, that user that logs in will then share a session host with one of the other users. That's great for where in situations where you need the best sort of performance whilst maintaining control and cost, but cost isn't the major concern. The performance and user experience is more important. In depth, what happens is the users will log on to basically one virtual machine or one that hasn't yet hit its session host limit, and the host will fill up with the number of until the max number of sessions, and then the next session host will start being utilized. Obviously, as the users start logging off and logging on, that's where the balancing starts to favor those virtual machines that are busier than those are less busy. Depth is really beneficial when that user workload is a little bit lighter. Office apps and that sort of stuff is beneficial. And where you want to minimize the concurrent number of concurrent session hosts that are running, reducing the cost overall. So the application groups, we've mentioned this already. There's remote desktop. That is that traditional, very familiar RDP type session. Get a full virtual desktop environment presented to a user, and the users will utilize that remote session as if it was a desktop running on their machine. But what we do find with some users, if they're not used to remote desktop type environments, they get a little bit confused about what is running in their remote desktop environment and what is running locally. So if you have a situation where users have, say, a laptop where they've got Outlook on their laptop and they've got Outlook running in the remote desktop, they might get confused by which one they should be using. So then there's remote apps, and remote apps are, if you're familiar with RDS, it's the exact same thing. It is basically application virtualization. Instead of sending back a representation of the entire desktop, it just sends back that application. And the great thing about that is that application, especially in Windows 10, acts as a native application. With Windows 10, all you'll see is a little glyph on the icon showing that it is a WVD application. And you can actually have that snap to the left, right, as you would with a normal application. You can also pin it to the start menu and the taskbar. So it actually acts like a normal application. So users can actually use that as if it was a normal desktop application, potentially not even realizing that it is something that's remote when they actually use it. And that's specifically useful for situations where you've maybe using all of Microsoft's Office 365 applications on the desktop device itself, and you've modernized into what Microsoft calls that modern workplace approach, but you have some legacy applications, maybe an old version of Sage or something like that, which you still need to have access to, but the users have gotten rid of their server rooms and all their servers. You've migrated that to the cloud, and instead of presenting a client on the desktop, you create that remote app version of it and present that down to the users, meaning that you don't have to manage it from a single location, and users just access it as and when they need it. So all those concepts can be visually represented in the following. On the right, you have the object model that for the ARM-based version of WVD. And then on the left, you see an example of how that's all put together. You see the number of users globally distributed. In this case, you have an engineering team and a sales team. The engineering team has access just to a desktop that is provided by a personal desktop, so they get that dedicated virtual machine, whereas the sales team, they're either utilizing a remote app or a desktop, and that's being provided by that pooled environment. So some of the requirements for WVD. Licensing, probably the least fun part of this. The only thing that you really have to pay for from a licensing point of view is a Windows E3 or E5 license, and that can be bundled as part of your Microsoft 365 package, or you could get yourself a Windows 10 VDA license. That all allows you to utilize a Windows desktop environment as the session host rather than a Windows server. If you want to run Windows Server as your backend infrastructure, you will require an RDS-CAL with active software assurance. Unfortunately, there doesn't seem to be any way to utilize SPLA licensing cells, RDS cells for that at this point in time, even though cells actually would work for a RDS solution that you present within Azure. On the technical side of things, there's a few things that you'll generally require. Obviously, one is an Azure Active Directory, so an actual tenant. If you're working with your customers already, then they probably, and they have Office 365, then they should already have one of these. So not much needed there. On top of that, you also require domain services, and that can be of two approaches. That can either be Azure Active Directory domain services or your traditional Windows Server Active Directory that's synchronized with AAD. If you're already working with customers where they might have some on-prem file servers or other services that are requiring Windows Server Active Directory domain services, then they most likely have some domain controllers on-prem as well. So that could be utilized as part of the solution. Obviously, if you're going to be presenting the solution to a customer, they will need an Azure subscription, and that's obviously that billing boundary that will contain everything and all the resources that will be presented to users. So if you are reselling a solution as part of CSP, for example, it could be that you're doing it by indirect with us, obviously, and you can present that into their environment, that Azure subscription, even if they utilize Azure with another partner, you could have that separate and covered through CSP. Then the Azure virtual machines, those are the session hosts that are required, obviously the bare minimum that you would need in terms of Azure resources. And in addition to that, optionally, there's some profile storage, and that would be some SMB3 storage for FSLogix profiles, but can also be utilized for some other things. On top of all of this, there will be a few other resources that you'll probably want to use, like Azure Monitor and Log Analytics for diagnostic purposes, Lighthouse if you're going to be managing multiple customers. So there are a number of other resources that may be required to manage this entire solution or just to maintain it. So just to go into a bit more depth about the cloud-based identity. So what happens when a user logs into the WVD client or the website is they'll first be challenged for their credentials, and that would be effectively a Azure Active Directory username and password, and they'll be authenticated through that. At that point, if there's any, because it's Microsoft's modern authentication protocols, if you've got any conditional access or anything like that, that's when that will trigger, and then they get to see their host groups that, their application groups that have been assigned to them. So before they access any other servers, those servers have to be domain bound, and that, as I said, can either be domain service, Azure Active Directory domain services, or it can be traditional domain services from on-prem. At which point, when they log into that, they'll be challenged again for username and password, and effectively that is their domain services password. So if you're working with a customer who doesn't have Windows Active Directory, a good option would then be to consider Azure Active Directory domain services instead of spooling up a domain controller in the cloud and managing and maintaining that, utilize this service. Obviously, it's not exactly the same as Windows Server domain services, but it provides you everything that you need for this in this account, and make sure that it ensures that you don't have to manage and maintain that operating system and domain services and everything else related to that. You just have to manage the actual service and make sure that that's working, and you don't need to worry about any replication servers, AAD connect. So the other option is that hybrid option, which we have also mentioned now. So if that domain controller is sitting physically on-prem, then obviously you'd need some sort of connectivity, secure connectivity between Azure and the customer's resources on-prem. So that could either be express route or more likely virtual private connection to start with. You'd also then need Azure AD Connect to synchronize the identity from the on-prem to the cloud and make sure that that's working, because the username and password does need to be synced between both. The next thing that may be of consideration for the solution is FSLogix profiles. So the FSLogix technology is something that Microsoft bought out a little while ago and has been made available through WVD mainly for the profile containers aspect of it, which allows you to decouple the user's profile from a session host into a VHD that's sitting on that SMB-based storage. The beauty of that is the session host doesn't obviously contain that particular user's profile, and when a user connects to a pooled set of resources, they might not get the same virtual machine or same session host that they had previously, and that means that if they have FSLogix in place and that profile containerization, the user doesn't need to reset up things like their Outlook profile, Teams, that sort of stuff. It's automatically going to be provisioned as part of it. For the user, it's going to be as if they connected to the same thing. Their desktop's going to be the same, their apps are going to work the same. There's going to be no real change between moving between different session hosts. The other options that FSLogix includes is that app masking, which is really good if you want to create a golden image and have it more generalized than having multiple images for different host groups. So you can actually just mask off different resources. That can be applications, it can be fonts, it could be printers, and a whole bunch of other things. As long as you can map that off, then you can specify by group management what sets of users have access to what set of resources within a virtual machine. And then there's also Java redirection. So if you have numerous applications which require Java and various versions, and we all know how much of a nightmare that can be, the Java redirection aspect of FSLogix can also help make sure that the right application is using the right version of Java. So FSLogix for the profile container does require some SMB3 storage, as I've mentioned. Here are two options that I would recommend. There is a third option, which would be create your own file server, storage spaces direct or something of that nature. I'm not going to mention that because I don't think that's the right way to go. But the two options that could work really well that we've seen with our customers have been Azure Files and then Azure NetApp Files, which has been around a little bit longer. At the moment, we're tending to recommend Azure Files more so than Azure NetApp Files, especially for smaller implementations. Azure NetApp Files, as you can see, that has a minimum capacity requirement of 4 terabytes, which can be quite pricey for environments which have less user requirements than would require that full capacity. In terms of the storage, one thing to bear in mind is the performance of that storage, and in the recommendation section we will go through that. There is a limitation on IOPS in Azure Files, especially on the what is now known as transaction optimized, what was the standard tier. So that's limited to something like 10,000 IOPS, and that also applies to the new cool and hot tiers. So some servicing and management. So one of the things that we speak to our customers a lot about is how do they manage a session host or pool of session hosts once it's been deployed. So one option would be to use whatever you used before. So if you have a third-party product that is supported within Windows 10 multi-session, for example, then that should still work. If you're using SCCM, then you'll probably need to upgrade to the latest version of Microsoft Endpoint Configuration Manager. I think it's version 2006 to be able to manage WVD correctly, especially Windows 10 multi-session. Alternatively, you could use things like Azure Update Management for patch management. And then there's the shared image gallery, which we'll go into in a bit more. I've included the Azure Image Builder. I'm not going to talk too much in much depth about that, but it is something that's currently, I wouldn't say it's mature enough yet at this point to utilize, but it's definitely something to look at. It is still in preview, but give it a few months and I'm pretty certain that it'll be worthwhile to look at. So just bear in mind that Azure Image Builder might be an option moving forward as well, and that's keeping things more in that infrastructure as code concept. So the shared image gallery, session hosts are just Windows Azure virtual machines in the back end, and when you create your session hosts, you will specify an image. Obviously, that can be from the shared image gallery, and either you can use one that's predefined. Microsoft usually provides 3, so that's usually the latest version of Windows 10 multi-session, and with or without Microsoft 365's apps, for example. You could create your own custom image based on one of those images, and then what you can do is then save that back into the shared image gallery, and then you have control and maintenance of that rather than Microsoft. The great thing about that is then you can add some additional configuration within that, some additional applications that are pertinent to your environment, and then it's just you then deploy that for your resources that are as you see fit. From the image, you can see that the blue icon has been distributed to both the east and the west, whilst you can see multiple versions of the black edition sitting just in the west. Now, one thing to bear in mind is that from the point of view of disaster recovery, if you do the shared image gallery option, it is worthwhile to make sure that you distribute your images into multiple locations, just in case your region has a failure and you need to be able to recover somewhere else. So we don't go into too much depth in this discussion, but if you are thinking DR scenarios, think that you can build in, you can either have a replication of your virtual machine sitting in a secondary location. So if you're in UK South, you can apply that, you can replicate using Azure Site Recovery to UK West. That's one option for keeping those virtual machines or a DR scenario. The alternative option is to actually automate your build process using a shared image gallery, that customized image that you then have deployed both in UK South and UK West. And when the proverbial happens, you can just rebuild everything in the secondary location rather than replicating. That keeps your costs down and allows you to automate things. So that will work really well in situations where your SLAs to recover are a bit more flexible, so that you can actually rebuild the environment quickly and automated using shared image gallery and a few other technologies that we'll discuss in a moment. So something that I find really exciting at the moment, it's still a bit new, is something called MSIX App Attach. So this allows you to dynamically deliver applications to desktops. So one of those things that come up with image management is, how do I get more applications installed on those virtual machines? Well, as I said, you could utilize existing services that, such as Microsoft Endpoint Configuration Manager. But another option would be to decouple that application using MSIX app attach from the actual image into a virtual hard disk and deploy that and attach that to a session host as and when required. The beauty of that is that you have a very lean session host that is, you could consider it as ephemeral, as something that is disposable, and as and when you require some additional software or something to change, all you need to do in terms of the application is potentially do that within the MSI app attach, add and remove it as you need it. It can actually happen in real time while the user's working. You know, you could deploy, say, the example I've seen online or something like Notepad++. The users don't have it, you app attach it using some PowerShell, and users will automatically see that and be able to utilize that. So it's quite beneficial, and that acts as a, I don't want to use the word container because that's automatically start thinking of Docker, but it's compartmentalized version, a packaged version of the application sitting in a virtual hard disk that is sitting on a file share somewhere, and just attached to the virtual machine when required. One of the benefits is when I mentioned earlier about disaster recovery, if you go for this lean session host using a shared image gallery version of your golden image, you deploy that to your environment. You then have the MSIX app attached, and then as you can see in the image over there, your user profiles will also be sitting else outside of that session host. So your session hosts become very much disposable and something that you can just disregard. So when it comes to things like major updates to OSs and patch management, what you could end up doing is just updating the shared image gallery, redeploying that to some session hosts, having the MSIX app attach occur for all the additional applications on top of that when the users log in. And then obviously the user profile comes along with them because that is kept separately too. So Microsoft has been providing session host auto-scaling scripts. Currently, the WVD solution doesn't provide a built-in native solution. It utilizes some logic apps and additional services in Azure to actually provide this. That is provided by Microsoft. It's available through GitHub. Microsoft has a whole bunch of documentation available for this in their Microsoft Docs pages. If you get hold of the PDF of this, hopefully those links will come through and you'll be able to access that. So one of the benefits of the auto-scaling is you limit the number of virtual machines that are running at any given point in time, obviously highly reducing your costs and not requiring, say, reserved instances or anything of that nature for the virtual machines as they're needed. The scaling logic tends to be based on, making sure that the virtual machines start up at a given point of time, but obviously you can modify that if you have more dynamic requirements. So if you're using depth-based session hosts, load balancing, you could just make sure that, okay, when your session host hits a certain capacity, spool up another virtual machine. That might be something possible doing your own custom solutions based on the scaling options provided by Microsoft. So some recommendations. This is, you can consider this recommendations and some best practices, things that we've gained from working with our customers and insights that we found from exploring and research. Okay, so multi-session sizing recommendations. This is quite a big one. If you've used the WVD calculator, which we actually go into a bit later, you'll see that Microsoft has defined 4 sets of workload types, and that corresponds to this table here. This is actually from that link that I've got at the below there, and it's very good to know what each of those workload types are and what they actually refer to in terms of sizing, so you can get an idea of why Microsoft, especially on the WVD in pricing calculator, actually selects the number of virtual machines it does. What we're seeing is that for most customers in most environments, the medium workload type is required for a vast majority of situations. Light tends to be a lot lighter than one would expect. And when I do quotes for customers, I tend to do two. I tend to do a medium workload type and a heavy, just to give that, especially if I don't know exactly what the customer requirements are going to be, I give those two as a better ballpark estimate of what they could expect in terms of costs. Medium being the one that we see most apparent, especially if you're doing more traditional office type workloads where users are maybe not doing I don't know, Excel documents with massive numbers of VLOOKUPs is one example I've seen of one customer was having some problems where they needed to increase the size of their virtual machine from 4 cores to 8 cores, just to make sure that when those multiple users are doing those VLOOKUPs, they happen as quickly as possible and the users aren't impacted as much, which makes a big difference. Also, if you're uncertain which virtual machine type or family to select, the DSV3 and ESV3 are very useful. I tend to go for ESV3 just to increase that RAM. In most situations, I find that RAM is more of an issue than compute. So unless you know compute's going to be an issue, increase the RAM before you increase the compute size. Just for your benefit, for most of the sizes of the ES and DS, where say you've got a DSV3 versus a ESV3, the ES will have twice the amount of memory than the DS. So some other general VM recommendations. Always use premium SSDs for production workloads. It's some of the mistakes that we have seen and bottlenecks have been around that OS disk struggling with too many sessions on a session host. If you're doing some test and dev or you have some pooled desktops, not pooled desktops, personal desktops, that's where maybe standard SSDs will be useful. I don't generally recommend standard hard drives for these scenarios. Might be cheaper, but the user experience can be quite dreadful. One thing that we have seen just in general with EUC, but WVD as well, is the perception of bad performance is something that tends to drive user experience more than the actual. So the perceived performance tends to drive a negative consideration of the solution. So try to make sure that you optimize as much as possible where possible. If you're doing single session hosts, so that there's personal desktops, 8 gigs of RAM is normal, and 2 physical CPU cores, so 4 with hyperthreading. Remember that you need to have a look at the ACU's documentation to understand how Microsoft, for a particular family, carves up a physical machine's threads and physical cores. The V3s and above tend to be hyperthreading related. So if you have a D4 SV3, that'll tend to be on a host which is split out at 1 to 2, as in 1 virtual core is equaling 1 threaded core. Whereas some of the older solutions, say the V2s, the D2, the DV2, those would be 1-to-1 mapping with physical cores rather than threaded cores. So keep that in mind when you're selecting what host to use for your session hosts. The B series burstable VMs, I don't tend to recommend these for production workloads. They can work for very light workloads where there's no real requirement for much computational performance. Again, this comes down to how the B series burstable VMs work in terms of allocating CPU resources. They're cheap for a reason. So that link over there, or just Google Azure B series and go through the understanding of that and how much of that resources you get and over what period of time you get access to those compute resources. Something else we're seeing now is more and more customers trying to do more graphically intense workloads within WVD. Obviously, Microsoft has a number of options, both NVIDIA-based and AMD-based for high-end graphic workloads or things that require GPU. Obviously, there's technological differences between the AMD solutions and the NVIDIA solutions, but if you need something that's a bit more affordable, the NVAS V4s, if they are available in the UK at least, can offer a much more affordable GPU option. You might need a little bit more work of getting them working properly in WVD. The drivers weren't recently baked into the environment as they are with NVIDIA. So you do need to add some software into there to get them working, but they do offer some really promising value in terms of cost for a lower spec virtual machine. Another thing that's worth knowing is just the way the remote sessioning works. So that presented image that the user is getting, if they are doing some more graphically intense workloads where color accuracy is required, then they're going to find that that's not necessarily going to work well with WVD just because of the way the color, the subspace sampling works. So you're not getting potentially exact accurate color compared to what is being shown on the back end. So if you've got the user in Photoshop who's doing some photo editing, that might be a concern to those sort of users. The other thing is that the frame rate is capped at about 30 frames a second. If users are utilizing more like Wacom tablets or anything that's more precise in terms of control over their cursor and the software, they might find that they lack that sort of precision that they would have on a local desktop. Alternatives could be utilizing something like Citrix or VMware because they offer slightly different options in terms of the protocol that they use, or in those cases, it could be that those users might need a Mac or a PC or whatever they want to use to do those workloads. Not all workloads might suit WVD or a desktop virtualization. So some Azure Files sizing recommendations. This is more specifically for FSLogix profile containers. So just be aware that the account name can only be 15 characters, that the premium tier and the standard tiers operate and are resourced differently. One thing to bear in mind is the standard tiers, so that's the transaction optimized, the hot and the cool tiers. They are limited in performance. They're limited to 1,000 IOPS, but they're also limited in megabytes per second. If I remember correctly, it's something like 60 megabytes per second and read, and I think it's 40 write. Azure Files Premium, on the other hand, its performance is based on how big you make that share, up to 100,000 IOPS. And ridiculous amounts of gigabits per second. Azure Files Premium, unlike the standard Azure File Premium, when you create that share, it actually provisions the entire share. So if you say that you're going to create a 3 terabyte Azure Files Premium and you only utilize, say, 10 gigs of that, you're not paying for 10 gigs, you're paying for that 3 terabytes. Whereas with Azure Files standard, you can create a share which is 3 terabytes, only use 10 gigabytes, you only pay for 10 gigabytes. Unfortunately, what we're finding is that in most cases, and you can see that from the table on the right-hand side, in most cases, Azure File Premium shares are going to be required. That does add costs in comparison to Azure File Standard, but the performance is that much better. Overall, it does work out, still can work out quite affordable. And if you're going for much larger solutions, so the 4 terabytes onwards, that's where Azure NetApp files might become useful. Azure NetApp files does tend to be a bit pricier than Azure Files Premium, but it also adds a bit more performance in certain respects, as we saw from the previous slides. And this rule of thumb comes from FSLogix. So you need about 10 IOPS in steady state, so as a user is just working ongoing per user session, and you need 50 for that login and log out. So that's where that login storm happens within WVD. You might be familiar with login storms with other EUC desktop virtualization technologies, VDI solutions. So 50 IOPS for that login and log out. We have seen some customers who have been using standard and users are just struggling to log in, taking multiple minutes to log in, and that's because they just don't have enough capacity in terms of IOPS to actually log in fast enough, say at the morning or something, when a lot of users are going to be doing that. So some configuration options for FSLogix. The first two are pretty much required. You need to make sure that it's enabled. This is especially pertinent if you're creating your own image from scratch and you're just adding the software in rather than utilizing one of the predefined images in the gallery. And then obviously setting your VHD locations. I believe it can support up to 4. The next 4 are just useful. So the first one, delete local profile when VHD should apply. Basically, if you have a pre-existing profile on a session host, so if JobLogs logs in and there's a JobLogs profile that already exists on that disk, they won't get an FSLogix profile created or utilize their FSLogix profile if it already exists. By setting that registry setting, that will make sure that that profile's deleted, it's not saved, and the FSLogix profile is created and or just attached. You can also set your size in megabytes. This by default is 30,000, so 30 gigabytes. You can change that if you want to keep a better hold and control over that sizing, just to make sure that those VHDs don't scale out. Obviously, those VHDs are dynamic, and it'll grow to the size in megabytes. Another useful thing is this flip-flop profile directory. So generally, when you look at the folder where you've got those images stored, it'll be sid_username. That's not very useful if you're in a hurry trying to find a user's profile disk to be able to resolve an issue. So if you use this flip-flop file directory name, it actually changes it, and I personally think this should be the default, to username and then the SID. This just makes sure that you can find that user profile a lot better, because when you look in File Explorer, it'll be listed in a more useful manner. And then volume type, this I would also recommend is to change that format to VHDX. You know, there's better compatibility with the likes of PowerShell. So as I said, the FSLogix profile disk is dynamic, and what you're going to want to do every so often is just make sure that those files, those VHD files are the most optimized that they can be, compressed, or so what happens is when a user logs in, they start doing stuff in that profile, adding and removing files. That virtual hard disk could potentially grow to that size in megabytes, but if they delete stuff, it doesn't count. You know, it doesn't diminish in size at all until you do some sort of action. So it could be that maybe once a week you have an automated process which goes through. If as long as the user's not connected, you can attach that VHD in the PowerShell, say through something like Logic, maybe not Logic Apps, but say an Azure function, and automate the process of compressing that disk to free up any space that might be, that white space that might exist in that virtual hard disk. And that helps you maintain that FSLogix storage size. So you can keep that on the limits rather than maxing it out. In terms of some antivirus exclusions, this is documented in the FSLogix documentation, but it's just worth to mention here. There's certain things that files and processes that you should exclude if you are installing, especially third-party antivirus solutions, just to make sure that they're not eating away at additional, your CPU cycles. Obviously, everything additional that you do, if you, especially in a multi-session environment, if you've got antivirus running for multiple users, you could be chewing up half of your, or a good proportion of your CPU resources by just checking these files and processes out. Another thing to consider is to enable diagnostics. So basically using Azure Monitor. We've seen some customers who haven't enabled this, and it is very beneficial when things go wrong, and things are likely to go wrong or cause some sort of concern. Some user will mention something about performance of some sort, and it is good to have all of this centralized and being able to build up and diagnose what's going on in Azure. So you can build up a custom or use one of the pre-baked dashboards to have a visualization of what is going on, and hopefully rather than being reactive to supporting the solution, you can be a bit proactive. I haven't talked at all about Office and support within WVD. I think that's well known, but one of the things that we are seeing a lot of is the use of Teams within WVD, and there are some things that you need to be cognizant of. Now, one thing to make sure is that it's been a while now since Microsoft has released their AV redirection, so make sure that that is installed, but also have just your network, make sure that that's appropriate enough for the type of workloads that you're going to be running within Teams. And then within FSLogix, the Teams cache and the team files, that can actually get quite large. So if you want to keep a better control over that FSLogix profile disks, just make sure that you're excluding some of those files and folders, just to make sure that you're not keeping those sort of things in your FSLogix profile disks which don't actually need to be there. Those would be more cache-like stuff. And then on the right-hand side, you can see some sort of bandwidth requirements for certain workloads. One thing to do is to remember that Teams will always prioritize audio over video quality. So video quality will drop down if it needs to. You've probably experienced that yourself if you're using Teams. And you will also see that at the higher rates, especially when you're doing group calling, video is downsampled as well, just to make sure that it's as optimized as possible. Those two links over there just are basically the Microsoft documentations for the two sections that I mentioned there, the Prepare Network and the FSLogix stuff. So one of the other things that we speak to our customers a lot about is how to quote up for their customers, especially a WVD solution. So some things that we put into play just when we, especially when we don't know enough about the customer's environment, there's just not enough detail to be able to go back to the customer and say, this is an exact cost. To be able to give that ballpark figure is to make sure that you have a good understanding of the number of users that are actually going to utilize the system at any one time, so that that concurrency, and also the number of named users. That also affects your licensing requirements. So the WVD Windows Virtual Desktop, if you add that to the portal, it only supports a minimum of 100 named users. Obviously, the workaround, if you have less users than that, is just to adjust that number accordingly. So use 100, and if you only have 30 users, and your concurrency is 90%, you'll have 27 as the concurrent users. If you also notice in there, if you change the reservations, you might actually increase your costs, and that's because of the fact that it's expecting you to use that auto-scaling scripts, and you'll see that it's set there for 220 hours, and then you'll see a number of machines at 510. The 510 machines are actually added to those 220 to get the 730 hours. So if you need to know how many machines are going to be running at all times, those will be the ones running at 510 hours in the calculator, or just look at the number of disks as the number of machines. So the number of machines that'll be where you could apply reservations would be the number of machines that the pricing calculator states are running 510 hours. For the FSLogix profiles, just add a storage account. Make sure you set that at file storage, and then usually premium performance tier. One of the things that Microsoft recommends is a minimum of 30 gigabytes storage capacity per user for their profiles. That is across both WVD and RDS. That might be too large for your users. Again, if that's the case, then obviously change your FSLogix settings accordingly. But if you don't know, assume 30 gigabytes for your users as a worst case scenario. Could be more, could be less, but 30 gigabytes tends to be a good middle of the road. The other thing that to add in, just because it can add up quite quickly, is the bandwidth, the internet egress. So as a rule of thumb, I just use 30 gigabytes, and one of the reasons I do that is because it's a lot easier to work, tends to be a lot easier to work with, to round those numbers up in terms of the bandwidth, because the bandwidth calculator only allows for up to 500 gigabytes. The next level up is 1 terabyte, and you can't do 1 point something terabytes. So just round up, use 30 or 25, depending on the thing. If you want a more accurate number, you will need to know a lot more about the user's environment, such as what screen resolutions are they using? Are they using multiple screens? Are their workloads being updated more frequently? But 30 gigabytes tends to be a good estimate, usually quite an overestimate, but just being able to reflect that in that cost so that you can come up with a true value. On the right-hand side, you can see something I did earlier today, which is basically just a demo environment for 100 users, 90 concurrent users, and then 5 users in off-peak hours. And that's using all the recommendations I've come up with before. And then I've associated that with 3 terabytes of FSLogix, Azure Files Premium, and 3 terabytes of bandwidth egress, just to cover all of that. And that comes down for 100 users to just over £1,000 a month, according to the calculator. So you're looking at, for the named users, you're looking at about a little over £10 per user, which is quite an affordable number. Obviously, on top of that, you do still have your licensing requirement, and obviously, as if you're a partner and selling the customer those licenses, those could be an option for you to upsell on the licensing as well. So one last thing is desktop optimization. So this is very pertinent for Windows 10 multi-session environments. There's a lot of stuff in Windows 10, especially in the Windows 10 multi-session, which is just going to add to your consumption of CPU cycles and resources, and your users are never actually going to use them. These include things like AppX packages, which are running in the background, services that are just running in the background which you don't need. And removing those is very beneficial, and it can result in up to 10% additional performance overall over the entire virtual machine. So one option, if rather than trying to figure it all out for yourself, is to utilize this virtual desktop optimization tool, which has been made available as a community tool by a number of people. Go to aka MS Optimize WVD to get that, and just run that. Now, I would recommend running this after you build your session hosts. One of the reasons being is that a number of those app packages, when you go through sysprep, it's actually, and you then build a new virtual machine after that, a lot of that stuff is then going to be re-added. So run this after the build of a virtual machine, a session host. You can add this as a custom script execution, and you might need to tailor it a bit for your own needs, such as turning off certain things that aren't actually required. But highly recommend that you optimize the environment for your users just to gain that additional level of performance, which might mean that you can actually bring your virtual machine down in terms of costs, or just reduce the number of virtual machines, session hosts that you're running for a particular pool. And that is it.